So I'm actually going to do two things to fulfill the promise of the meeting invite. I'm going to talk a little bit about Netconf and Yang, the two protocols, or the protocol language combination that we particularly like, and what we believe is the impact on the industry with that. And then we're going to head into talking about what we do as a company, which is largely based on many of the fundamental features of Netconf and Yang. And then I will try out a new demo. Okay, first time. You guys seem friendly enough. So, well, with some odd mens out here. But have at it. Okay, this is going to be really boring if you don't interrupt. I know people have varying types of interest in these things, so please guide me through this. Otherwise, this will be long, winding, and boring. My background is in network operations. I left that quite some time ago. I've been very, very interested in actually network management, but with a particular focus on configuration management over the last 8 years or so. As I said, I really like Netconf, and when I saw the OpenFlow vanity plate down in the South Bay, I said, you know what, I need to have the Netconf plate. So it's literally parked in the garage down here. We can all go down and take a look at it later. Oh yeah, also I moved from Sweden about a year ago, so be nice to my way of speaking and my way of presenting here. And the fundamental start that I have, and this is part of actually a presentation I did for Nanog, so forgive me if some of you were at Nanog. Don't believe the hype, right? Don't believe the whole SDN and FE thing. Since I moved here, I've been to every large service provider in this country. I've been to most of the very large data centers and most of the very large enterprises, and they all work out of this. They have no configuration management, no network automation. They swivel their chair when they do stuff. And the runners up to the swivel chair is the printer and the Excel sheet and the Word document. That's literally what every large service provider uses to order and provision services in their network. And it's a pretty fundamental problem, and this is what it looks like in every network I know of. They have configuration scripts, a lot of network engineers, and configuration file backups. And this works great if the frequency of the change in the network is low, and the complexity of each change is low, and it's really cheap to fail. Right? It's really cheap to delay things. All these three are changing quite dramatically over time. When I left networks in the late 90s, it was okay to saunter around the office and kind of type things in for another VPN that day. Now we're being pushed to show networks that are doing tens of thousands of pretty complex changes a day. And of course, this requires people to get out of the loop. And I've had some interesting quotes over the last year. This is from a particular multi-service operator saying that this is not something that we can just power through because it's literally a brick wall. So the origins of Netconf and Yang comes out of this insight, right? And just to be very quick, there used to be a meeting at the Sunday before the IETF meetings where most of the large service providers were present, and they discussed how to keep the internet alive for another half a year or until the next IETF. During one of those, they had a show of hands who uses SNMP for configuration, because that used to be what you would use for configuration. Nobody showed their hands, so there was a gap. IETF went to work at it, did a lot of road shows, went to Nanog, RIPE, Lisa, and a couple of other places, and they found out that this is prevalent, so we need to fix it. So we started on doing a workshop on network management, and the reason I have this slide is for that RFC. It's really, really good. It's a report from all these workshops and all these interviews with service providers on what the future of configuration management should look like. The depressing thing, of course, is that I think it was released in 2002. So 12 years ago, and most of it is very, very similar today. So here's a couple of favorites. You know, basic things like would be cool to have a distinction between configuration and state data to do backups of only configuration. Transactions would be cool when we make complicated changes across many devices. It's horrible to fail in the middle because you have to manually roll back, right? That's not a good thing. Database schema, that would be cool. Something to allow the network equipment to describe the data set that can be manipulated. And of course, all this led to the invention of Netconf and Yang. So we kind of took input from operator requirements, a lot of the CLI best practices, because the CLI, again, is simply an encoding, right? And it works on something. And quite a bit of SNMP experience. Some of the SNMP old-timers kind of gave up on reinventing SNMP at this point and came flooding into the Netconf and Yang teams instead. So Netconf is a protocol to manipulate configuration. That's all there is to it. It is a domain-specific protocol. It's not general. It's not HTTP. It's not other things. Makes a distinction, of course, between configuration and state. We got change validations, we have change transactions, selective data retrieval. All of this is part of the protocol. You don't have to reinvent these things in your client or in your management software. It's all there. And it literally does provide some of the more basic kind of 60s computer science fundamental idioms that we need for structured and distributed systems that need coherent configuration. The stack kind of looks like this. We have a number of transport protocols. The only one that seems to survive into networks are SSH. There's an RPC layer. There are operations. So again, the protocol describes the operations. You don't have to invent them or reuse them from other parts. And there's a content layer where configuration data travels over the network. It's an XML-based protocol, which today freaks most people out. I usually say don't think about that because you use a library, don't you? So shouldn't be a big problem. For some it is. A really cool thing with Netconf is that it got something called capabilities. So during a hello exchange, when you actually connect to the router the first time, the router will tell you what it can do, both in terms of the extensions to the protocol, which is very basic in its mandatory set, and also which models it implements. So clever code can actually figure out from this capabilities exchange what type of device this is without matching on things like vendor, product, version. Okay? So these are references to formal data structures that we will talk about in a little bit. This is really cool. You know how offline SNMP MIBs used to be a problem, or undocumented REST calls with no structure to it was a problem? If you care to implement this, or if you care to force your vendors to use this, that kind of goes away, which usually makes the programmers, the management layer programmers, very happy. And it's got 3 databases, and this is going to actually also come into my demo later. The running database is obvious. That represents what the network device is doing. The candidate database is something you create when you start editing things. So it's your scratch pad. You go about changing things in the candidate database until you're happy. Then you commit it to the running database. You ask the box to bite on the outstanding changes that you've created in your candidate. And of course, there's a startup. So it's prudent to copy your running to your startup if you want these things to persist. The common operations, I won't bore you too much with this, because you can get things, you can get only the configuration. Of course, you can edit and copy. There is session management, there's locking. Of course, when you manipulate things on a big honking router, you want to not allow other people to do things, right? Just again, fundamental things. There are transactions. You can commit things with a timeout. You say to the network element that make this happen, but if I'm not back in 10 seconds, something went very wrong, so roll back. Everybody who has typed away themselves from a management address will be very happy to see that this is a formal way of avoiding that, a very structured way of doing that. And again, these are parts of the protocol. You don't have to invent it. Of course, there are things you want to do that's not related to configuration, things like reboot and ping. So there are RPC extensions to this as well. And the anatomy of Netconf sessions, right? There's one of the really strong inputs we got from the equipment providers was that don't make this hard to implement, because then literally we won't. So based on these capabilities, you can make it very short and very tiny, maybe for CPEs. So a company like Deutsche Telekom is now starting to use Netconf for their CPEs in their homes. And all you do is the hello exchange, and you edit config directly in the running database, right? It immediately bites. So no transactions, nothing, not needed for CPEs. The ambitious version does a lot more, as you can see. We do locking, and we do a lot of things to allow for, again, atomic and distributed chain sets. Example exchange, well, it's XML, but you can see that there's an RPC layer. Here's an edit config message, and the config is actually part of the payload. And then you validate, you ask the box to validate the change, and you commit it. So for bonus points, here's how to do formal two-phase commit-based distributed transactions. Your management system, I'll show you this in the demo, connects to and locks the participating network elements, independent of whether you're building a VPN or you're moving a VM. Whatever you do, you connect to them and you lock them. You edit the candidate database, your scratch pad. You can do assurance checks, because at this point it's bitten. So ping, burn-in tests, whatever it is you want to do. When that's done, you confirm the commit, you copy to startup, and you release locks. And you will find that this is a very clever, and I'd like to say watertight way of doing transactions in a network, okay? And if something happens, oh, good, wow, that's a couple of minutes in. I was hoping for shorter. Go.
How do you know that the system has the correct homeostasis?
It's what I think it is running, in not only the configuration, but what's running on it for me to actually do it. The way you talk to it.
So that's part of why it can be tricky to implement the protocol. You can't lie over Netconf, right? So it does drive certain complexity into the database management on board the device.
So have you considered a extension such that I run this and at least it verifies it and let the end host kind of figure that out or implement that?
Absolutely. There are many ways to skin this pig, right? So if you look at implementations like the ones from Juniper, you can trigger scripts, right, on the device because you may not even have visibility into the contextual data that you need to declare this success. But it does get horribly complicated, right? So you have to be a little bit careful about it. So that was a good starting question. Are there any other questions brewing? Oh, that's 3 more. Great, go.
How does locking devices work with SDN controlled devices, where you might have a controller changing config regularly, and then users, you want to lock these 3 devices, you can break your controller if you can't access them.
Right. Now, and this is my snapshot from what I know from the ONF where I contribute. Transactions were deemed over-engineered for OpenFlow, the protocol. Okay, so we literally didn't want that. So having multiple controllers working towards the same logical switch or the same implementation of OF wire is a no-no. You're not supposed to do that. It gets horribly complicated. So, having said that, you literally can't have overlapping data sets between a lock-based system like this and what the OpenFlow controller can manipulate.
Sorry, were you saying you can have multiple controllers talking to the same switch?
In OpenFlow you can't, or you shouldn't, because that would be intractably complicated. There's no way to tell what the end result will be if you had 2 controllers.
Well, the latest protocols actually provide explicit support for doing that, and not just. But the hard part is trying to let these guys cooperate in a way that's not going to burn the world down. If, for instance, one way to cooperate is one owns layer 2 and another owns layer 3 and up. That's what an example. It's easy to understand. But I wouldn't say that the ONF is against having multiple controllers talking to one switch.
Then I stand corrected. But then you know better. There was 2 more questions, I think, unless they went away with.
A good job implementing this so far.
Say again?
Who's done a really good job implementing this?
So Juniper was really early out the gates, right? And I'll get to Yang. They didn't have Yang, but that's coming. If you ask the right people at Cisco now, and I do have explicit okay to say this, they have really good builds, and we know it's really good because we helped, for their virtual version of iOS XR. And without diverging too much, the other product our company does happens to be a Netconf agent, right? So we have about 80 customers that, to various degrees, have turned on Netconf on their devices. So there's a couple of others, and actually I'm going to get to a slide with some logos on it.
Is there an open source version? Is there an open source version that you guys have released? Or?
We're supporting one. And so I'll get to that as well, but there's 3 open source projects right now for the server side, and there's a big variety of libraries for the client side.
How ubiquitous is the support? Like when you're dealing with large service providers, like how much of a heterogeneous environment can you have and still successfully use Netconf?
It really isn't there yet. I'm going to get into the product, but when we started the product that I'm going to talk about 4 years ago, we knew that Netconf and Cisco CLI. If we had that, we had 80% of the SP market, right? And unfortunately, it hasn't changed much. But, as some clever person once said, management protocols needs to be alive for 10 years before they start making their way into the actual instrumentation code on the actual shipping equipment. And we still don't have, from my point of view, and I'm happy to take other views, we don't have any competing as useful protocols, right? There are talk about RESTconf, OVSDB has its world, right? So there are a couple of things, but for this core problem space, I think that's about what we have right now.
You mentioned iOS XR as it got into other like iOS XE and
It's
XOS.
coming down the list, but XR is first out the gates.
Okay.
So we got this standardized in, I believe it was 2006. Netconf was standardized, and people said, what about the data modeling language, right? We can't just blindly find out what the box is doing. We need a way to represent this. So we had a lot of back and forth. Building new or inventing new languages is normally a non-starter. You don't want to do that. That's usually a huge time suck. And you usually come out with something that's equivalent to something else. Then you will regret the time you spent on it. So we had to, for example, prove to the IETF that XML schema didn't work by getting the XML schema inventors and having them tell the IETF that no, XML schema is not the same thing, it's different. So after a couple of years and with a lot of input actually from the SNMP or SMI-NG people, we ended up with a language called Yang. The history of the name is that it's yet another next generation, ironic attachment of the two. But now it's just Yang. It is a way of describing to the outer world the data set that you can manipulate on network elements. That's the fundamental thing, right? We had readability as a primary criteria just to do better than SMI and do better than XML schema. It's hierarchical. It's not object-oriented. That's the only thing that kind of may open up some discussions, right? So if you're looking for something that can represent multiple inheritance, and things like that, this is not your language. So the way this works, and I'll tell you about that later, is that if you have UML diagrams, you can transform it into here. Extensibility is very, very big. Of course, we're building standard models in the IETF now for interface configuration, IP configuration, basic routing, I2RS, and of course the vendors need to be able to easily decorate, their magic stuff on top of the basic backbone of this. Supports definition of operations, so you can do again things like ping, you can do like fault management and performance management and many things. The really important part is that it's a very formal language, right? It's got a type system, it's got structures, it's enough to drive implementations. You're not supposed to have to code much once you understand Yang. It can drive the things you have. And of course, data modularity and versioning rules, also very important, ties back into the capabilities exchange. You're supposed to decorate your Yang models with a version so you can tell exactly and formally what it is that the box is doing by matching on versions. And again, this is, our CTO loves to talk about it as the SQL for the network, right? It's again a formal way of the network to describe for you what it can do. And it really changes the game for software people that wants to manage stuff. And I don't say that lightly. It actually changes the game also inside the network equipment providers, right? So when you do a new build of any of the big equipment providers, they can ship the Yang internally to their testing team, to people turning Yang into DocBook and write to technical publications. The side effects of having this type of formality is actually quite profound over the line. Yang is up here, obviously describes what kind of content can travel in the operations and obviously the structure and semantics of the configuration data. And the RPC definitions allows you to extend the RPCs outside of the basic ones that are in the protocol. So if you put this all together and make it one big nice system, again, the system can, when you connect to a router or a switch, you can figure out what the models that are currently running are, what their versions are. You can check with your own library, do you have them? If you don't, you can ask the box to send you that particular schema for interface configuration or for some extension to interface configuration. And you can update your applications and drivers based on that formality, right? It gives you that whole loop, like in SQL for the network. And we all know what SQL did for the database industry. It created the relational database manager, and I think that was a good thing.
So you would query the device and it would send back via Netconf Yang information that your system would then understand and would be able to take additional actions based on that data. Okay.
And it's fully formal. It describes the fact that policies have a reference to declaring the name. It knows the exact structure and syntax of an IPv6 address. You can capture that in your templates, which is in your web thing, right? It drives that formality.
So, Carl, one of the holy grails of network management is a new device goes out there and I don't have to update my application to understand what's new. How close is what you're describing to that nirvana?
What this does is that it drives a different way of building management systems, right? It kind of reinvents the manageability part of our management system industry, right? So people are trying to move away from SNMP-centric stuff that it used to be, right? And if you start internalizing what this means and you build your system around it, then yes, we could get closer to that. Again, this is the fundamental building blocks that we've been missing on the network devices. Now we can do cool stuff on top without millions or tens of millions of lines of pseudo-transaction code and fragile scripting towards a particular set of CLI commands and things like that. Was that even an answer? Okay.
Close, yeah.
Does this have a security architecture to it? So that not only who can do it, what can do it, what's accountable, and then within it, being able to say certain capabilities, certain objects have, or whatever. And stuff.
I suspect you've spent time in the ITF based on our chat down here. What happens when you propose something like this is that the security people come at you like a ton of bricks. And first they say just no, or prove to us how and why. So there's two things. Transport security, we kind of outsourced that and said, we'll do transport mappings. It was much harder than we thought, especially when it came to TLS. Actual user identification in TLS is non-trivial, especially if you want to describe it uniformly. The second thing is that we have something called NACM, or Netconf Access Control Management. So it's literally a Yang model for describing ACM or AAA rules. CRUD-based, based on role-based access control, and it spans, of course, both model and instance data. So very powerful, or powerful enough that we could get through that needle's eye and be done with it, or at least go forward with it. So it seems like SSH is the only thing that people know how to deal with, and NACM seems to be good enough.
Sense that nobody, good enough in the sense that nobody is asking another standard, or that everyone's implementing that?
Yes to both. Yes to both. And also you pass, again, it's horrible. You pass the security toll gate, or whatever we should call it, with the ITF is usually, yeah. And and operators trust SSH by some magic.
Is the NACM implemented though?
So the NACM is what you get is authentication and authorization, right? So you get authenticated based on credentials from the transport mapping, and authorization is then based on the NACM stuff.
But there's access control. Is there access?
The access control is on the data and the content layer, right? Yeah. While authentication and the transport security is done with the protocols. But like I said, there was very little in terms of formal username string specification in TLS, right? And we need that because otherwise NACM doesn't work, because that's the key into your rules.
So just continuing on that, when you start with a box out of the factory, does it respond to anything? And should it? Because first time somebody calls it up, there's a security. So the question is, how much information does it give that first pass? And it's a remote call.
So bravely, we've been chartered to start approaching that problem. We've hand-waved this far and said that's out of scope. So what we're working on now, built on Netconf and Yang, is what's called zero-conf, or zero-touch configuration, based on reverse SSH. And that's also a can of worms, and we're just recharted in the ITF, so that'll take time, because the ton of bricks are still on us for that. So hand-waving for now, and we'll probably cover it in the upcoming specifications on best practices for it.
So short of that, after the box is booted, is there something that can tell you it hasn't been hacked already?
Not tied to these technologies, no. No. I mean, it's an abomination. You know, the operations today is just horrible. People load configlets from USB sticks. No, that type of integrity is just not there. It isn't.
So does this mechanism have diagnostics behind it, such that at least I'm informed of what's happening? So the scenario that you just gave based upon putting a USB stick and it's configured, right? Does this notify via some trap or whatever? It's a method.
Yeah.
Basically saying this has been changed.
What we have in here, I usually don't bring it up in this because it makes it longer and deviates a little bit, is something called Netconf notifications. So there's actually a time-structured, replay-based notification system that you may implement using Netconf that should be used for those things. Based on transport, though, it's TCP or SSH, whatever, so it has other scaling properties than UDP-based traps. So it's
I'm sorry,
right.
that's why I said method.
Yeah. Right, so the Netconf way to do that would be with Netconf notifications.
Have those been implemented yet? Or?
Yep, some of them have. Yep. But people kind of freak a little bit when they think SNMP or notifications, and they have slightly different purposes in life.
How standardized are the Yang definitions? Meaning, like, say I want a routing table from X, Y, and Z devices, or
We'll get to it. Actually, this is further down the line. So just quickly, to the question. This is one of the ones that I do get a lot. OpenFlow does that right now. OpenFlow as a protocol kind of manipulates on the driver layer, on the switch pipeline layer, while Netconf, you could do that, but that would be strange. Usually works on the OS layer and up. So it's more an application, network application configuration management protocol rather than a switch pipeline manipulation thingy. And the general question is, of course, what about my favorite protocol? I prefer it over Netconf. Well, usually the way I talk about this is that Netconf is an entire stack, right? It provides everything from the transport protocol mapping through RPCs and operations with all its semantics, locking and all that good stuff into the content layer, right? The ones that I usually get back is, I like REST. Well, that's great, but it's kind of transport protocol and half of an RPC. I like TL1, yeah, same thing, right? There's not much of a formality or whatever they have. Now, may or not be a good thing, just that you have to reinvent the upper part of the stack that you don't cover from the get-go. Here we go. So the momentum, of course, Deutsche Telekom came exploding out the gates here, driven by a very strong wish to have Netconf and Yang, and so they had the arm up for many of the very large equipment providers that are now rapidly building it. Snapshot here of some of the big ones. We have Yang specifications in all these four standard defining organizations, and I think there will be more joining the fray here. There's a couple of software companies that are building things to it. Of course, we do it. The Open Daylight project has what's called an MD-SAL structure, which is based off of Yang. There are clients for it. There are various types of frameworks to use if you're building, both if you're building proprietary solutions, but also in terms of open source. I don't have open source here, so there's two. One called FreeNetconf and one called LibNetconf. That's available at your favorite repository. Both are you're able to use them without paying too much. And on the client side, there's a couple of language bindings. Python, probably most mature. There's a Go implementation I saw. There's Ruby, there's Java, there's Perl, of course. This is something that we are trying to move so people can get more languages into this. We have a nice pattern on how to implement this, so this should be fairly straightforward to extend.
that's just a Python Netconf library?
Yes. Yep. IETF activities, we're rechartering, so Netconf over TLS and reverse SSH, which is part of the discovery and securely bringing things up. Maybe doing a REST mapping of the Netconf semantics. DHCP v6 option for server discovery. So something comes up and can listen to its DHCP v6 responses to tell where's my Netconf server, where's the thing that manages me.
So if you want to experiment with Netconf and Yang, do you have recommendations? Like, what kind of lab would you build? Like one of these open source ones? Like if you were trying to sort of get more exposure to it, see what's going on under the hood.
Yeah.
How would you go about?
I would use if I have business with Juniper, I would use their virtual stuff. If I had business with Cisco, I would use their virtual stuff. If I didn't, I would look at the open source examples. So look at LibNetconf and the FreeNetconf.
And for Cisco, that'd be the CSR 1000V. What would be the?
So it's the iOS XR VR. So yeah. And in the language group, we're working on, to someone's question here, basic interface configuration, bringing just the basic interface structure, which took quite some time to get the big vendors agree on a universal interface structure. Adding IP addresses, of course, of both types. Basic routing, so static routing at this point. System management, like MIB2, reboot the thing, how long has it been up. Configuring the SNMP server, or the agent, actually, is, ironically enough, one of the things. Driven by daylight, we're also galloping into topologies, so formal way of Yangifying topologies, the interlocking or interdependencies of network elements. Many people have a whole lot of problems with ACLs, right? Especially in multi-vendor environments, so they're very strongly for building a Yang or formal standards-based ACL management. And OSPF and probably ISIS is probably going to come up pretty high on some of the large service providers.
So the HPv6, is that for sort of the cable environments?
Yes, I mean, that's where it kind of comes from. That's where the questions was raised. Also TerraStream, Deutsche Telekom. Yeah.
So any relationship between these efforts and TMF, mTOSI, or?
So mTOSI, if this is down here, mTOSI is like up here, right? It's very abstract and it's very service oriented.
All these interfaces is built by device.
Yeah. So what this will help the TM forum though, because they have this abstract point-to-point transport idea, right? And this could be formal references into unique and well-defined interface identifiers in the end. So it's a kind of bottoms-up effort to get to the TMF level stuff.
Is there vendor energy behind the ACLs in particular yet?
Huh? Say again.
Is there vendor energy behind the ACL standardization work?
So layer 4 to 7 vendors are slower in this domain. They still make a huge amount of money out of their single panes of glass. So they're slower. So you will see the big incumbent equipment providers that have firewalls move on it first. And then the others will follow.
What's the sweet spot of devices? You said routers, that's what you talked about.
Yeah. Routers that are frequently changed with complex things and where it's expensive to fail, like I said in the beginning. SP, not core, but the edge where things actually change. So PE is probably PE and maybe one step up and step down depending on which vendor. Some of the data centers where they do pretty strange hop by hop tunneling and things like that, it can be very efficient. Some of the virtual layer 3 routers today have Netconf or are growing Netconf, so that could be a very useful environment also for transactions.
Any security devices?
Outside of the kind of the big companies that have security devices, also no, not yet. Getting there. I don't have any names right now, but some of them are definitely going there because again, especially the ones that selling to large service providers have heard Netconf and Yang and probably are sick and tired of it and are turning around to their own engineering saying, what do we do? This seems to be happening. But it's glacial, right? Changing stuff that sits in the network elements is just horribly slow for many reasons.
Compared to what?
And
The standard?
well, don't be mean to the standards. We're trying to agree first. See? Okay.
I'm going to sneak one in as well then.
Go.
So earlier you were talking about this being configuration management rather than SDN. And so you've distinguished between OpenFlow being more on the SDN side of things and Netconf being configuration management. But then, as you've just said, you might want to configure hop-by-hop routing, hop-by-hop, or tunnels or whatever.
Yeah.
Via Netconf, which is SDN. So do you see a boundary there, or is it just a thing that will flex over time?
I try not to have too many strong opinions, but I usually use this and say if what you're doing, whatever it is you're doing to network need driver layer access, maybe you're inventing a better switching protocol, maybe you're improving on OSPF, then you will find that the vendor support for that layer of access will not be there. Right? Not saying that the protocol itself, this associated from anything else couldn't support it. It's just that that's not how it works. But you're right. And I'd say that we have several people I know that could comment on this, Nils. That what is SDN is kind of going up and down here. Some people have it up here. We have large service providers that say that their VPN provisioning system is now SDN, right? Just that they're configuring with CLI, just like they did before, but now automatically.
I've seen that, looking cursorily at the OF-conf stuff, that that they're using NetFlow to configure the interfaces, like is this Ethernet full duplex, and what speeds is it, stuff like that. They're also, interestingly enough, configuring all the tunnels. Tunnel endpoints are configured with OF config,
Yeah. Which is Netconf and Yang.
which is Netconf.
Yeah.
I don't know why it's not part of the wire protocol. I hope someday it moves into the wire protocol, because I think those things should be pretty dynamic. But today, you want to start set up a new VXLAN. You're going to be doing with Netconf and Yang. The higher level stuff I haven't noticed.
Okay, so let's switch into me gear. So what did we say? How much time do I have left, Kirk? 8:30. Good, perfect. But that's good. I think that's perfect. So we're going to talk briefly about where I work. Tailf Systems, Swedish software company. We take a lot of interest in these things. Headquarters in Stockholm, Sweden. All the heavy lifting, all the big brains are there. Us beautiful people are here. We have our office down in Santa Clara, where people still bend iron and build routers and switches. About 85 customers worldwide. A little bit of background about the company is that we actually, when we founded the company, we started on a piece of software that we sell into the equipment providers, okay? A piece of software that many, actually 65 of them, are using on board their network elements. And what I want to say with that is that our DNA, where we come from, is actually under the hoods of all these network equipment, right? So we know that software environment too well. And I'm still amazed that the internet works, having seen what's in there.
That's the client piece.
That's what sits. If you log into one of Cisco's high-end routers, one of the CLIs you will end up in is from us. Okay, it's integrated into the network equipment. That one is called ConfD, or Configuration Daemon. What I'm going to talk about today is the other one. Around 2009, when we had gone on with this for a while, we got really strong signals from some very large service providers and data centers that they wanted something that sits in the middle of the network, that would manage heterogeneous networks and provide a useful northbound interfaces coming out of that. So at that time, it was more about network automation and getting humans out of the loop, because this was pre-SDN hype, right? So we launched this product in 2010, had our first commercial customers deploying it at that point, but we struggled with language because people really didn't think about having software doing things massively to your network. They were more used to SNMP coming into your system than configuration going out. We have had some very, very interesting engagements. We're very happy since 2 weeks that AT&T is now choosing us for one of their strategic service orchestrators, and they have pretty massive networks, I'll tell you that. So we're getting this tested at fairly large scale. And some of these companies down here then, of course, use our other piece of software inside of their network equipment. Any questions about the company?
So NCS is largely used at, or will be used at AT&T and Deutsche Telekom.
Yes.
BT is using NCS too?
We were part of BT's, a couple of POCs that led to the ETSI NFV, where they used NCS to kind of prove their point. So it's lingering there. I don't know that they've rolled it out into any production networks. Make sense?
It's BT.
Yeah. It's in the lab.
Or in storage.
Yeah, right. On its own in a corner. One of the things, I've kind of gone through this, but one of the things that, having spent our entire life cycle as a company only on manageability, we've been compelled to go into many of the standards organizations and kind of help with manageability, because most of these kind of forget that when they invent new great protocols and ways of going about passing packets around. So Netconf and Yang, obviously, we care very much about that. My colleague is the editor of the Yang RFC. I do the Yang modules for the OF config to various degrees of success. We're in the NFV things with ETSI. We try to be a good industry citizen, so we have OpenStack plugins for the product that I'm going to show since Havana. We used to do things in TM Forum. We used to do things in the MEF. We've kind of backed out a little bit, while this is happening, kind of more on the network layer, and that the impact will come later, I think, for both MEF and TM Forum. So here's what it is. Here's what I'm talking about, and here's what I'm going to show. It is a piece of software. It's literally a Linux daemon. It doesn't come attached to any particular appliance. It doesn't come attached to any particular set of big and expensive database backends. It literally is standalone. You can use it on a VM or on bare metal Linux. South of this system, there's usually a combination of a lot of different protocols. We came out the gates with Netconf and CLI just to cover, or Cisco CLI, just to cover Juniper and Cisco, because we wanted this to work in existing networks. So no flag day, no waiting for a new protocol, or even worse, for a new protocol version. We added a long tail with things that people still use, SNMP, REST, TL1, SOAP, many other things, just to get coverage for what they're doing. On top of this system, there's usually a combination of management applications and, I should have a ponytail here, network engineers.
Beard.
Both, probably just with click, click and ponytail beard. Right? Management applications ranges from things like workflow. We have companies that are applying DevOps tools on top of this. We have self-service portals. We have WAN orchestration tools. Basically, any piece of software that needs to talk through a useful and robust API to configure or manipulate the assets that they have in the network. I only half jokingly say, and I said this to someone before we started, that the main barrier of entry for this type of system is the cynicism of the network engineers, the fact that they've tried many times faithfully and failed spectacularly. That's what we're always up against when we go into any network. People, they sit like this when I start my presentation, and all I can do in the first presentation is have them lean in and not hate me. There's two things with this system that really stands out from previous generations. Oh.
What's the reason why they're pushing back?
Oh, but you know, when someone comes in and says, you know, all these systems that you've tried before, software that's supposed to help you manage, you know, your network and coherence, we have another one. So they're dubious. Dubious is too weak. They give me 15 minutes. If they don't hate me, they may extend that. So you have to be very fast in proving to them that no, this is vastly different. It is a serious, serious issue for a company like us. Yep. I've not been burned myself, but I have enough war stories that I do appreciate the pain.
Well, you also had a lot of success because you were seen as not trying to boil the ocean, but of course now you're trying to boil the ocean.
Let me see if you think that 10 to 15 minutes down the line. Mm-hmm. That was not an open, that was a, I already know you will. Okay, two things that stand out. Okay, the first thing is that it's entirely driven by data models, and you guys have figured out which data model language we use. So we use Yang for the entire thing. We apply it in two layers. So we have device models. So device models are faithful representations of the structure, syntax, and semantic of whatever the protocol you use to talk to the box. So if it's Netconf, it's what you fetch from the box, which will give you that for free. So we can build this network element driver, you know, without human intervention. Sounds good? The other end of the extreme, and the elephant in the room always, is Cisco-style CLI. There is no formal schema anywhere down the stack. We've looked, there's nothing in there. So you have to write the device models yourselves. We happen to have a huge coverage for the parser dumps for the major operating systems, but you can't infer updates, okay? So the device models for
You map Yang's CLI and you make the Yang representation of for all the different variations.
We do the starting point, and surprisingly enough, some customers take those models. We don't hold them close and iterate over them. So the Yang model would, like you said, it would look like the CLI parser dump, right? Literally stanzas, types, references, ordering. It's semantically richer than just the text representation of a show config, and I'll show you why that's needed. But it's a representation for that. So everything you need to talk to needs to have a Yang model for it. The Yang model doesn't have to cover the entire data set, only the configuration or the parts of the configuration that you care about. So if you're doing VPNs, you don't need DECnet configuration parameters, okay? So it's something you can sneak into your network and start with parts of it, no flag day. You attach a little bit of scaffolding to the device models that knows how to talk to these particular devices. So if it's a Cisco, you need to know that it's SSH, and you parse the password prompt, and you go into configuration mode. When you go into configuration mode, the entire behavior is inferred from the data modeler and the manipulation of that data model, okay? So when you load a new device model into the system together with a little bit of scaffolding, it becomes a network element driver. It also becomes the schema for your database. So when you've loaded the driver in, you can point it to let's say, vendor C. Vendor C. And you ask the system to sync from. You take the textual representation that comes over that SSH, you map it into the database, and then you get rid of the textual representation because, again, it's not detailed enough. There's much more you need to know for this. Many of the things that I will show you can't be done with textual representation or textual manipulation. Now you have it here. Now you can use any of the northbound interfaces to navigate the data structures, their configuration, change it to your heart's content, and when you're done, in the candidate, that database is coming up now, you ask the system to commit this to running, which means that NCS commits it to the network. Okay? That's the kind of workflow. You sync from the network configuration according to whatever protocol it is, manipulate that instance data, and commit it back to the network. Great.
Manipulate the instance data.
Yes.
Okay, so to me, there is a time sequence. It's just not get everything in.
Right.
If I'm going to commit, I have to know how to orchestrate,
Right, right. So that's going to be the next step up. So this is device by device. So it's a very device-centric thing. So it's going to be a faithful representation, just as if you were doing it on a device-per-device basis. Okay? Service models, on the other hand, that's where it gets interesting. Now, the service models are entirely owned by the customers. We have a lot of starting points and examples, but it literally reflects what the network is doing. So for a utilities management company in South California here, they use it for smart meter management. We have big, AT&T is using it for VPN. We have data centers using it for top-of-rack switch management or VM mobility for it. So it's literally a formal way to describe the syntax, structure, and semantics of the service instances that you allow into the system. Okay? So you feed that in together with a little bit of logic, which is either templates or Java, and then NCS knows that if someone instantiates a service, this is what we need to do to the device layer, but in the normalized level, okay, before we turn it into ordered set of commands or operations, depending on your protocol. The entire point of this is to minimize the effort to support new devices. Importing new devices needs to come down to a couple of days for big service providers, and even more importantly, to change your services over time without having to come back to the vendor, right? You may start with a VPN, and then someone's going to come up with the fact that, we need a three-legged VPN. So instead of going back to tail F, you iterate the service model and redeploy the service model. Jim.
How rich are these examples? Because much as service providers might like to talk about how they understand, my head is hurting just the meeting would have to gather on a large service provider to get a description of a service model that you actually believed.
There's some very pragmatic ways of going about it. You go into the people that are going to own this, and it's usually the network operations team. Sometimes this sits with the IT people. You ask them, when you're doing a change to your network, why are you doing it, and can we look at the work order? Because people just don't randomly type things in, right? So for service providers, they have printouts in Word templates. We can take that Word template, make a Yang model out of it, show them the REST interface. For people that work in data centers, it's usually we're deploying a new rack. Okay, so what is it that you have in your order, whatever medium it comes over? Let's look at the syntax and structure of that, put that into Yang, deploy it, and here's the CLI you can use on a service layer instead of using
So you start with the MOPS, basically.
Exactly. Start with the MOPS, start with a formal description, and then you bring in the people that own the network equipment, the subject matter experts, people that know their vendors very well, and you ask them for a target configuration, right? And then you write the mapping. That's literally the way you go about doing this.
You find the guy that makes the MOP actually work.
Yeah, absolutely. I mean, the data is always there. It's just that sometimes it's in Word templates, sometimes in people's heads or in a pink worksheet, beside the screen. But people do things to their network for a purpose. And that purpose can be reflected using service models, is our experience. So that's one thing, model-driven, okay? The second thing is transactions. Of course, one of many reasons why people hate previous generations of this is that when you're doing more complicated changes to your network, you may fail halfway in. And it might be hard to go back to where you were. You have to call in the CCIEs or the JNCIEs or the Arista certified people to manually do it. And when you've done that, you find it's hard to remediate. So that database quickly goes out of sync. And if you look at inventory databases today, they're about 60, 70% correct if they're really well kept. which is a huge problem for everything you want to do up here. So with transactions, the fundamental promise from the system is that either the entire change that you're proposing happens in the network and everybody who's participating is happy with it, or we will be back to where we were before you started. And that builds kind of the trust, especially from the network engineers, but also for the programmers that can take away many strange fault situations if they can trust that their manipulations to be transaction safe. And the first questions I always get, so I'm going to beat you to it, is that what happens when, not if, someone changes the configuration of one of the participating devices? Now, good question. What happens is that as part of a two-phase commit, we always check sync. So we want to make sure that whatever we're going to do, or the participating devices in whatever we're going to do, are in sync with our own, or with NCS, understanding of the world. If it isn't, we abort the transaction. We put it to the side, and since we have both the model and the instance data for the configuration of the network, we can allow the applications or the engineer to first of all figure out the exact structure of the change. So maybe someone changed a VLAN tag. They can also see that, okay, there are 5 services that references that VLAN tag. So this is probably not a good thing to have lying around in my network. It probably broke the VPNs. And they can then decide to remediate in either direction. Either say, well, the services will prevail, so we will redeploy the services, and the output delta will probably be just remove that VLAN and we'll be back to where we were. Or maybe they changed something else that looked good, and then we can just say sync from, okay, and drive that change into the database, and we're back in synchronization, and we can restart the transaction and keep going our merry way.
There was a method we did years ago, and that was the network engineer would always use the UI through the NCS. So they would go through there and do the SSH or whatever, and therefore that would interpret their change, and then that would be committed automatically back to the database. Right. Have you thought about doing that?
We need more. We need more for it. Hopefully, I will be able to show you that in the demo. That's not enough. We need more integrity and synchronicity to keep up with things.
Is there a sense of dry run?
Yes. Thank you for asking. I will show you 2 types of dry runs, which is also one of the things that these guys will never, if we hadn't had that, a lot of meetings would have been cut very short. Ed, still boiling the ocean? Okay. So that. So what I usually say is that we will never be a workflow engine. We will never be a full and formal inventor system. We will always be a network abstraction or service orchestration system. So we're always looking for people or applications that want to use this. That was the wrong thing to say. So we try to stay inside of a constrained problem space. That's what I'm saying. A lot of vendors support, we support a lot of vendors. Some of them are self-supported, like I've said a couple of times now. Juniper, you ask for the data model, we can synthesize the driver. Others are well known to people. Cisco, of course, most people know roughly how the parser dump works around about what they want to do. Some people are dragging their feet a little bit, are not really used to being orchestrated over, since they have their own single pane of glass. We see that the L2, L3 players are happy to do this because they've kind of given up. We see that the L4 to L7 players are more skeptical whether this will work. We see the service providers wanting to prove that this can work because it gives them a very nice set of features. And of course, important for us is that to show that we can do drivers for new equipment in a couple of days. So you can introduce new vendors without first of all asking for their permission to access their published APIs. Into your network in a really short time span, right? That's very important for many of our customers. And actually, if you summarize it, there's 2 things that people like. Support for new device types. If it's completely new protocol, around about 2 weeks. A lot of things in the system that makes your life easier here. An implementation of new services, which is what most network owners want to be able to sell back to whomever they're selling it to internally, externally, is that you can reiterate over your services in the order of days. Really quick on.
So what do those time periods mean in terms, I'm trying to put some sort of,
Right.
I mean, that's not a software model. I don't know what 2 weeks and 2 days means.
Right. So this is kind of the most salesy slide that I will have. So I'll give you the background. We came into a network that had Sienna, a lot of Sienna. We didn't have a Sienna NED, but we built one in 2 weeks. They use a very strange version of SOAP. So the scaffolding, the protocol layer, SOAP, and then the model of the structure. But it's kind of how long is a shoestring. Agreed.
Okay, so that sounds reasonable, but what's the 2 days? Nothing takes 2 days when you're done doing your design, doing your software, and all it is a red button. What's the 2 days?
So the 2 days is that, let's say you have a service. Let's say you have a service chain service. This is what this come out of. You had firewalls and you had load balancers. You want to put in DPI. So you want to start offering DPIs in your service chain. So the part that you have to do here, given that you then have support for the DPI in the NED, is that you have to extend the model to support inserting in an ordered list of functions the definition of DPI policy and make that happen through the system. That's the scenario this came out of. Does that make sense?
It's still not quantified in human terms.
Not really.
It's 2 days.
Yeah.
But is that one engineer 2 days, a whole team 2 days, or a whole company?
So in this case, very highly trained engineers, of course. You know, it's a best case thing, single engineer with these, but it's actually internal engineers that they have.
So one internal engineer, 2 man days to do this.
Yes. So multiply with 3 or 4 times if the customer wants to do it, at least. And maybe that can come down, but that's usually because they have to learn not only Yang, but also how to use Yang in this context.
And do you see this coming down to more like software cycles?
Yes. So one of the things that's really exciting, we see customers wanting to share service models, publish service models, which is really cool. So they don't have to reinvent their own VPNs or service chains, so the formal basic, and then they can augment, of course, to compete. But we do see it now. Many of both the service providers and some of the social networks up here and down where I live in San Jose, they talk a lot about spending on software engineers for networking, but they don't. So that's kind of slowing this down a little bit. We have to spoon feed a little bit going backward. Because there's a couple of things in here you need some basic understanding of computer science approach to these things that we struggle with.
You know, a set of network engineers that have been doing send scripts into something a little more modern.
You know how there's 2 extremes, people that want to do this and people that don't want to do this, vastly different. Assume they want to do it. A couple of weeks, of course, we have boot camps, things like that, getting started. Depends on the complexity of the service that they're doing. A couple of weeks to get them up and running. And of course, they usually have like 3 installations. One is based on a simulator that I'm going to show. One is based on their testing network, or whatever they call it, and one is in production. There was a question somewhere in here. Yeah.
So do you have a catalog of service models?
Yes, absolutely.
And we can also modify it.
That's the thing. Take it and run with it. That's what we want to happen. Don't come back. We're a software licensing company, not a professional services house.
So, have you ever thought about self-learning such that if I go into an organization and implement something like this, then you want to get the orchestration of how actually you what when and the workflow of it. And so basically you get your high-end engineers and saying, okay, you're going to do this type of change. What are the steps? And they do this phase, and you say, okay, I'm going to mark that. I'm going to do this one, I'm going to mark that. I'm going to do this one, I'm going to mark that. So you get kind of a learn phase approach. You ever thought about doing that?
We're thinking a lot about it and doing very little. The whole onboarding thing with people is especially in larger environments, is quite tricky.
Is there any dovetailing in between this and network diagnostics, whereas if something breaks or you're monitoring with the network, can you correlate back to configuration?
The only reason why people actually use our SNMP trap sync here is for that reason, right? Since if you can map the SNMP trap, like an IF down, to an asset that has a pointer to it from the service manager, you can qualify the trap and say that these services are now out. So you can actually do qualified alarms going north through any of these interfaces. And some applications are very interested for their own purposes. And it also ties well into more ambitious, Tivoli-based traditional things, because they want the end result rather than the noise.
So we have an audit record going that way of exactly what's happening at different times.
Right, yes.
Is it you're trying to make a standard out of it? Is it XML? Or is it
that's going to be so that is a very good question. It kind of ties into the discovery thing. We would love to standardize that, but that's down the line because it's the variance is too big over the equipment providers. Not only what protocol they chose, but also what the instrumentation look like, what they can do. But that would be very cool.
So then where do you see this meeting using the load and turn SDN? Because SDN at the top is start with the controller,
Yeah.
and then we meet you someplace down there, so that the software engineer can have an app. It just says, I want my app to talk to my customers. I don't care what the network is.
Yeah.
Turn the button, ask for the resources to do that.
So here's an example of what people are doing with NCS in an open flow context, okay, and some experiences with that. We were challenged by, and this I talked about actually, well, I talked about it like a couple of times. We were challenged, so when we get into these, or getting called into people's networks, they have already done the technology choices. See what I mean? We don't get to have a strong opinion about doing service chaining with metadata headers or controller-based or whatever. They come in with a challenge or with something that they want us to solve. So that's why I'm pretty weak or wavy on which way to go. So in this case, they wanted to use a PK8 OpenFlow switch to capture and steer traffic through a set of, well, networking functions, okay? They wanted a short list of vendors for each networking function. Some of them were virtual, some of them were physical. None of them had OpenFlow, right? They all had their horrible, horrible northbound interfaces, right? On top of this, they wanted a self-service portal, so people that already had their VPN could say, you know what, I want a firewall in my VPN. And then when they click that button, NCS then reprogrammed the OpenFlow switch for that particular VPN that it passed through to siphon the traffic out through an ordered set of these functions, depending on vendor and location. So we started with saying, there's got to be an OpenFlow controller for this. The problem with OpenFlow controllers in general, I'd say, maybe Open Daylight will change this, is that it's not the controller you want to manage, obviously, it's the applications running on the controller. At that point, there were no controllers that had a good framework for application developers to expose their configuration parameters north. See what I mean? They all assumed that the OpenFlow controller managed the entire service domain, that there was nothing outside of it. Our observation, and obviously I'm biased, is the opposite. There are many ways to use OpenFlow as part of your service chain or part of whatever it is you're doing. But to do that, you need a useful abstraction of the OpenFlow application facing up. So the way we integrate with these things, so we actually built our own controller cluster, which freaked most people out, including ourselves, because you don't want to do that, because we didn't find one. And we're trying to then influence some of the OpenFlow controllers to build that framework for northbound configuration interfaces, and we'll be happy to let go of this thing.
So that's just an adapter until you get what you want.
Yes, exactly what it is. Exactly what it is. Because, again, the service orchestration up here will include things like things that are manipulated by OpenFlow applications. We call them flowlets. But they need to be managed and configured in a formal manner.
So then your company's sweet spot is really that adapter at this point?
Yes. So there's, well, I'll be very frank and say that there's I'll make it even more general. Multi-vendor, doesn't care, right? We're not tied to any of the incumbents. We'll be happy to work with anyone. And showing how fast you can do these things. So people ask me then, okay, so Netconf survives and becomes the language for the entire network. Will your value go away? Parts of it will. Some of the immediate allure and interest will go away. But based on our experience, there's a lot of things that are really tricky in here that we're hoping we got right, that we think we got right, and that we're working on proving that they're right. And they could actually benefit from a Netconf-only network with strong transactions and this and that.
Do you have a good write-up on the primitives that you adopted and why you adopted it?
For
your design elements there. So XML is impossible to think about in terms of design.
yes.
But there's some sense of design in terms of the elements that you came up with and design with.
Yes.
And to understand that would be much more interesting than trying to look at XML.
So we have a Lisa paper that you may like that actually tries to go into that and talk about tree structured representations of assets and how easy the manipulation of them becomes if you can lay bare this problem space using that approach. So give me your whatever and I'll point you to it. Ed, how are we doing? Sleeping. That's even worse.
That's still service chaining at the edge.
It is. It sure is. You want me to change the entire network? That's a.
No, you're just,
I'm doing good. Okay.
you're advertising you're boiling the ocean when in fact.
No. I like that. Okay, so enough with the examples, and we're getting into a little bit of a time squeak. So let me switch quickly to demo mode here. And no, you can't go to the bathroom, because then you won't come back. So sit tight. So what I'm going to show you here, like I said, it's actually the first time I run this demo for you guys, or it is for you guys. So you have to be a little bit patient. So what I'm going to do here is to show you how to apply NCS in a data center where you want to drive VLANs across switches. So it's kind of a general case, but we have to have something as a central piece of the demo. Of course, the purpose of the thing is to show you how this works. So what I do here is actually start from a release of this system. And in this example, we actually have something called packages. And I think I mentioned that everything we're doing is released as packages. So in this case, we have a couple of packages for the service application that I'm showing. And what I'll do is I'll do a make clean all start. So this now builds out of the Yang modules, both for the service layer and for the device layer, NED drivers. It builds the service models that we can load into it. It loads it in, and it also uses another product that we have to simulate a set of switches with, actually we're going to use a couple of CLIs to do this here today. So it brings them up. So we actually have an NCS, and we have a number of simulated switches that is based off of the scenario with 2 data centers. So we're starting them up, and you can see the product names from them here. And I'm going to use a combination of a CLI, web UI, and I'll flash some REST for you guys and girls. Okay, so we're coming up. So I'm going to start with a CLI when this finishes. So I think I mentioned that the northbound interface is coming out of NCS is literally only for navigating and changing the data in the database. So I'll start with using our default CLI here when it comes up. So if I do this, I end up in something that looks a whole lot like a Juniper CLI, okay? And then I can do the magic incantation of switch CLI, and I end up in something that looks quite a bit like a Cisco CLI. And this feature actually turns out to be very, very useful for some people that are very, very hung up on what they're using. So it is just a way of manipulating the data. So you use this Juniper-style CLI to manipulate data that may belong to Huawei, right? So it's the look and feel. It's not the data structure itself. So the first thing you usually do, and I'm going to peek a little bit, in a system like this, well, first of all, I'm more of a Juniper guy. There's 2 important data trees in this system. One is for devices. So if we look at the show configuration, device, you will see that we have preloaded this thing with a list of named device entries. For every device, we have an address port pair. We have a couple of things for the UI, and we also have what's called a device type. So we know beforehand that this is an iOS XR device, either by manual intervention or loading it from an inventory database or using our discovery system. Okay, so a couple of these down here. The first thing you would do when you start to use this, and I'll probably have to do this a little bit, and you log into the UI. Is that you look at the device list here, and this is the exact same list. You can recognize the data. Now, Yang is rich enough that we can render it through either of the northbound interfaces. There's enough detail in there that you don't have to program for these things. So we have something called as I mentioned, sync from all devices. So while I'm doing this, I'm going to talk, because devices usually takes time to respond. What we do now is use the native application interface to go out and, again, fetch the native representation of the configuration, map it into the database, and throw away the text or throw away the representation. So that works. That's good. So what I can do now here is I can hit enter configure mode. No, let me do this first. Actually, I'll show you show configuration devices device. And now you'll see that there's a new subtree, okay, with config. So again, this is a Cisco. I used this SSH CLI to fetch this into the database. I'm now showing it through a Juniper style CLI. And of course, I can switch CLI. I just need to remember, remember the Cisco version of this, show running config devices device. And this is, of course, the same data. It's just that it's rendered through the Cisco CLI. Yep.
So, Carl, kind of a dumb question. So, if it's something in the config that it doesn't understand,
Ignores.
Whatever, just throws it away.
Ignores it. Ignores it. That's a good question. And the same data can now also be fetched using REST. Oops. So we can do, and you can see on the structure here, right, the running data store and devices. So we send that. And here's the REST representation of the exact same data coming out. OK, again, I'm the Juniper guy here. So now we can do things. We can do things like set devices device, and we can do over a span. So for ASR 0 to 3, and of course we have all the nice things, right? We have tab completion for devices that you have. So we can see that there's 3 of these. Our span notation is ... We started with hyphen. I'll leave it to the reader to understand why we left that. And in the configuration subtree of that, I need to qualify it actually with a name qualifier. There is an SNMP server config. Sorry, community. And all good demos change the community. So frob. It's not a pass-through CLI, so nothing happens to the network. It's now in my candidate database. I can always look at it with show compare. It's, of course, a diff-based notation. So you see that there are now 3 outstanding changes in my database that's waiting to be shot to the network. And of course, I can switch CLI and do show configuration. And we'll see the same thing rendered through the Cisco CLI.
Netconf used to have a mode where you could ask the system to the actual manage device to pre-process this and show errors.
Yeah, so let me show you this. So this is the device-centric changes. So now we get to the magic part, right? Where are we? Right, switch CLI. So now we can do commit, dry run, out format, native. So we can look at the potential output. Now these are easy things, right? So this is a Cisco command, right? But it's not very impressive. The next thing we do is commit, and this is good in the CLI, and pipe it through details. So here's where the cool things happen. Our customers usually use this, again, both for applications and people. So we need to be careful about transactions. So we lock things. There's a critical section in here where no one else can do changes. It's usually very short, right? Because we need consistency in the local database. There's a number of things that you can enforce up here, right? Configuration policies, dependency triggered validations, just simple things like don't reuse IP addresses in your network. If the incoming configuration change set includes an IP address that already exists, abort. And then you can start codifying declaratively, either in Yang or other ways, to check for things like that incoming. So you can take your things of your engineering rules and move that onto this system. Then we hit the prepare phase. Of course, in database terms, our running database are the network elements, right? So we prepare ourselves to talk to them. Now this is straightforward. It's only 4 devices. This is vastly different and more complicated if there's 10,000 devices. We connect to them. If we can't reach any of them, then we'll abort immediately because it's not around. We calculate the southbound diffs. This is a little bit involved, but we are careful to calculate only the minimal set of configuration that we send to the network. So if you change the name of your VPN, don't rip the entire VPN down and then up. Just use the native commands to change the name. Really important. Don't upset the instrumentation in the network unnecessarily. And then we go into the 3 steps in a 2-phase commit. And in this case, this is iOS XR. So prepare literally means the configuration command. Commit literally means the confirmed commit command. And the persist means going back and confirming that commit command. Okay? So this is actually a 2-phase commit backed change using the Cisco iOS XR CLI. Now, of course, we take rollbacks, right? So we can roll back 0, do another show compare, and you'll see that is the inverse. Right? So loading rollback means that you will now remove it if you commit. Commit that, and we're back to where we were. We're still only on the device layer, even though we used ranges, right? So there's nothing particularly new here. So let's talk about the actual application. So we go to data centers here. Let me briefly show you. Of course, we can render all the configuration out of these things also by clicking through here. So these are all working off of the Yang models and the content that comes from the devices. So if you upgrade iOS and that changes the Yang model, no need to reprogram the web UI. It runs off of the Yang. Okay, back to the data center. So what I'm going to do here, somewhat painfully, is that I will show you through the CLI how to set up a service. So the concept here, based on the Yang, is that you have connectivity, named connectivity with VLANs to it, that you have then attach endpoints to. So we're in configure mode, so we do things like, so set data center, so this is another subtree. So this is the subtree for the data center service. You can obviously have many services loaded, and people have many services loaded. So we have connectivity connection 1, so that's the name of our instance of this service, and I'll pick a VLAN from this printout here. And an IP network that I want to assign to it, that I also know how to whip. So I do that, and that creates a new stanza. And so I'll go into that, and I'll change some things to it. Connectivity, connection 1. And again, you can see that we're now in the candidate database, so we know that connection 1 is in there. So we can tab complete into that, and we set connectivity settings. Preserve VLAN tags. So for the entire VLAN here, we want to preserve VLAN tags. Of course, we can do show compare here and just say, look at the outstanding changes. Now, this is, of course, on the service layer. So we haven't decomposed into devices yet. This is still just making changes to the service layer. And we don't have any endpoints. We have declared the VLAN. Now we need endpoints. So we do set endpoint catalyst 0. And I, again, just happen to know this. 0/5, and we add a del switch to it, 0/2, and we add a another catalyst on the other end that I also happen to know is 0/7, top. And then again, so this is the entire service, compare running brief. This is enough data. This is defined by the Yang model to be enough for an incoming instance of this service. Now, people ask, don't do anything, right? Dry run. Show me what it is you're going to send to the network. So we have two ways of doing it from the CLI. So we have one version called commit dry run, and which is out format, or without out format actually, which will show you, and there's a lot of changes here. Well, I'll just show you this. These are the changes that we're making on a normalized database level before we decompose into ordered set of operations. So this is what you program for in the service decomposition step. So a lot of changes that we're doing here. And you'll see that even though there are curly braces here, because I'm showing it through a Juniper CLI, this is not specific to any particular vendor. And then we have out format native. I can't remember if we call it less or more. Now we send this through the network equipment drivers, and we catch it before we send it to the network. So now you will see the exact ordered output for the participating devices, right? And the way you go about this is that, you start with your service and write the decomposition, and then you talk to your subject matter experts about the output. Iterate until they're happy, and off you go. Point it to your lab network. When you're confident, point it to your production network. And of course, again, this is running here, right? So all I'm doing here is sending things to simulated network elements. So it's a nice environment.
When you attempt to undo this, are you going back to the original configs of each of the devices, or are you actually trying to undo it a step at a time?
So the really tricky part with this system, coming back to your question, was to do a generic Delta engine for Cisco CLI in order to go from any Cisco configuration instance to any Cisco configuration instance. And you need, again, a rich semantic model of the CLI to do that, because going backwards is not a question of no. Usually it can take very long and winding ways around the data space to do that. So we have, for each of these NEDs, we have a robust rollback mechanism, and they are more or less tricky to do. Again, Netconf comes with the protocol. CLI, especially Cisco style CLI, a lot of work.
But you do attempt to roll it back in an ordered way, not just revert to a previous configuration on each device?
We want to come back to where we were before in terms of the instance data in NCS database.
What's the methodology to get there, is the question.
So the way it works and the division of labor here is that there's the transaction engine with the tree-based representation, and there's the NEDs. And the NEDs, of course, we can talk about that for a full day, but they expose capabilities and callbacks. So it's not very tricky to understand the reverse on the database layer, but then you have to invoke the magic of the NEDs to translate that into it for you and report back that it actually worked. Does that make sense?
Okay, so you're not rolling back to a previous config, you're actually running commands that make sense based on the model.
Yeah. With the explicit intent, though, to come back to where you were, right? In the back first.
So, and the NEDs are specific in the Cisco case to a specific flavor of iOS and a specific version of that.
It's only specific to the protocol. The model reflects the version and the flavor of iOS. So the NED only knows how to talk over, over the socket.
Probably already thought about this, but when you're doing these phase commits, you may want to, in between phases, look at a service. Make sure the service is there right before the next thing. And then you're going to get into problems with asymmetry because a lot of the times when you go forward, going back isn't the same path. Right. And so you want to have markers to the point where I'm going back here and this is good enough, and I got to call in the troops.
Yep. It gets trickier in live networks, as you can imagine. And of course, what I'm showing now is a highly idealized version. And there are a whole lot of decorations here. There's pre-commit script, there's hooks in the critical region, there's post-commit scripts. You can stack services, like you said, ordering, do this first, and if it fails, then call this service instead. And it comes down to the ability for the network engineers to express what they want to do and how to do it.
Yes, and you see what this gentleman said over here about boiling the ocean. So when you're going back, being able to have this roadblock where it's good enough. I don't have to go the whole way, but it's good enough that it's kind of stable where I can call in the right people to kind of take it back for.
Yeah, and the transaction engine is quite configurable as well.
You're doing a serial-based rollback, right?
It's
You're not trying to do anything clever. A, B, C.
No, at the same time, even. At the same time. There are two boundaries.
A, B, C. You're rolling back to A. You're rolling back C and B before you touch A, or you're trying to be clever and only roll back A?
Only roll back A. Is it over-engineered? That's a comment I get. Okay.
And there are serial and parallel operations too.
So they're parallel inside the constraints of transactions. You can serialize in the prepare, serialize in the commit, and in the persist. But you're not allowed to serialize across them because you lose consistency when you do that.
So a couple more minutes, Carl.
Sure, go. Okay, so
While you're typing, is there any topology awareness in CS?
in this demo, there's actually topology awareness. Now, knowing what you know and where you work, we don't have topology in the same sense, same tight sense that again some of the controller-based approaches does. Topology is something you add to NCS. It's not a primary function, right? So people gravitate towards this mostly when they have kind of loose expectations on it. It's not highly dependent on topology. We can integrate with PCEs and things like that and outsource the topology things. See what I mean?
So you can feed in topology from wherever it happens.
Yeah, absolutely. So we commit this, and the service will come up here any day now. Good, we have a service. So we can bring this into our web UI-based workplace here. Now we can start doing things that are horrible, for humans. We can start changing the VLAN, right? We can change this to 776. This usually gets network engineers running, right? And of course, for us, what we do, just in the web UI, we do another commit dry run. Pretty straightforward for us to compute the ordered set of changes that needs to be made across the devices that participate, first in the normalized version, and then in the native output, right? So here's the output that's actually required to change the VLAN for this service that spans 3 endpoints in 2 data centers. Of course, this is a web UI, so all you have to do, well, let's make it really hard. Let's save this. I'm going to speed up, Kirk. So that's cool. Changes saved. Of course, we can also add things, so we can hit data center 2. We want to add Catalyst 3 to the devices. We'll pick a well-known Ethernet interface. Apply, same thing here. Look at the commit dry run. This is what's needed to add one of the switches on the edges to this. Save that, and we can make it even more complicated. And this is the final touch. Let's say we change this guy again, or girl, to 778. And in the same, I mean, we can do arbitrarily complicated changes in the transaction. So we can say, actually remove Catalyst 3 in the same transaction, right, in the same change set. Of course, this is that's just another run for our transaction engine. So this is the output to do that. And of course, here's the native output to do that. A lot of text comes out of it. Things that people generally don't want to type every day. And you have to believe me when I say that all this is available, semantic parity across all the northbounds, or REST, Netconf, CLI, whatever you like. So we can save it. And the final touch, Kirk, before you faint, is that we also do, of course, rollbacks on the service level, right? So if we allow this to finish, we can look at the rollback file. So if you look at the most recent rollback, you will see that this is a rollback based on the service before you decompose, because your infrastructure may have changed, your endpoints may have changed. So we can load that in, save it, OK it, and we'll put back that switch, and we will change the VLAN back when the spinner is done here. That's it. Any questions? Yes?
So if you were to do something, for instance, like adding one endpoint and taking another one away in the same transaction,
yeah,
what guarantee have you got the two endpoints in question? You're not doing the add before the remove, for instance.
You,
so they could talk to each other when they shouldn't be able to.
So if you do nothing, it's a transaction-based system. So it's going to think that as long as it's in a single transaction, it'll eventually be fine. Right now, there are protocols that doesn't behave like that. You need some ordering. You may actually have to split them in several services or stacked sub-services with assurance tests in between. It gets arbitrarily complex, just like the networks we have. Yeah. I'm hoping the silence is of awe. It's just, wow, I can't believe that.
One last question.
Right.
Question. Tail F.
I
know what that means. Does it mean what I think it means?
It's absolutely the Linux command.
Thank you.
Yeah.
Why put that configuration? Why not just Why that?
So young people ask me why not tail capital F, right? That will follow log rotate. And I don't have a good question because I'm old. I'm showing age. It's because the founders had another company called Bluetail, and this is the tail F on Bluetail, actually. And also it's a strong culture marker. People do double takes on show floors, things like that.
Well, I think we're pretty much done, so thank you, Carl. I appreciate that a lot. Any other questions, any other statements? We're pretty much at 8:30, so I don't want to overstay our welcome here, so
Thanks for organizing, Kurt.
yeah.
Thank you very much, Kirk.
So
Thanks,
I don't know
Thousand
what we
Eyes.
want to do next time, so if anybody has any opinions on what they want to do next time, let me know. I'm sort of up in the air on what our next talk will be, but thank you very much, Carl. That was cool.
Thank you much, Kirk. Thanks for having me.